Okay, so started the recording. So yeah, so as I understood, right, two of you want to learn SQL with Power BI. So any idea what is Power BI?
It's like we create a dashboard. Like suppose if something in the raw data we present into the data visualization format, like in the dashboard format, or something like that. If we want the raw data to produce into the data visualization format,
Yeah,
that's what
so
I.
how do you build the dashboards in Power BI? At the backend, you write SQLs, right, to fetch data
Yeah,
and to build
exactly.
dashboard, right? So when you use Power BI, that is basically a reporting tool. And there are a few other reporting tools also in the market, like Tableau, right? Power BI is the most common used and easy to learn, right? So it's very easy to pick up, but ultimately at the backend, if you see, it's all SQL. Until and unless you are good at SQL, you are not good at joins, you won't be able to show the exact data in the dashboards that you are going to build, right? And the data you will be sourcing from a data warehouse, right? You will have a collection of tables wherein you will have to join multiple tables and then fetch the data and build your reports. So there will be a separate team who will just populate the data warehouse. So there will be humongous amount of tables, billions and millions of data, and somebody will be managing that, right? So this is all interlinked. So okay, so that now that we know the how SQL is beneficial to us, what are the career paths that we can take, we can move ahead with today's topics. So I will start with some basic topics like what is data. We keep on hearing the term like data engineering, data scientist, database engineer. So every in this all career paths, you can see data is common, right? So what is a data? Can somebody tell me? Like when you hear listen to the word data, what comes in your mind?
It's like someone names, place, or details regarding the
Yeah,
anything.
collection of
It's
information.
Collection of information. Okay. So Parikshit said like it's a database information like names, age, phone number, etc. So any other answers? Okay, let me tell you what is data. So data is everything. Everything around you is data, right? You are using a phone. You have applications. You log into those applications with your credentials like email ID, phone number, right? That is some kind of data. So all these applications have their own databases. So they store these informations at their backend, right? Like for Instagram, right? I guess many of you must be using Instagram or Facebook. So what you can do there, you can post some pictures, right? You can post your status in WhatsApp. You can store contacts. You can send messages. So everything that you do in those apps is all data that the app companies collect, right? So Instagram, for example, it stores your images, right? It stores your, nowadays there's a trend of reels, right? So they will store your videos like 15-second, 20-second videos. It's all data, right? Data is not only like a table format structured data like the age, phone number, or something like that we can quantify. Everything that you see now is data. It can either be videos, it can be images, it can be some logs that comes up, everything is data. So in data engineering world, we don't see that there is a garbage. Everything that we have is data. Everything that we have is meaningful, and we want to use as much of information from our surroundings that we have. So that's what data is. So as you see in this slide, like what is data? It's a collection of distinct small unit of information. It can be used in a variety of forms like text format, numbers, media, bytes. It can be videos, it can be anything, right? It can be stored in a piece of paper. So database, what is a database, right? So database is collection of data that we store somewhere so that we can reference it later. Like you guys have been to a school, right? So in school, you fill an admission form. So that admission form goes as a file in your school's, some rack. They will store all the files. So that file is the database for them, right? So every year you pass on a class, all your report cards or all your fee details will be stored in that particular file, which has been created for you. So that is nothing but a database management system. So your old school are storing your information in form of a file, and then they are collecting multiple files for multiple students, and they are storing it somewhere. So that is what we call as database, right? In older days, it was all manual. We were storing in files. Now it's all automated, right? So if you still go to government offices, all your work will be done on files. They will bring some very old file, 30 years old, 40 years old, all rusty. Some files will be eaten by bugs also, right? You will not get information there in those files. So they will get all those files, and that's their database, right? But in modern world, it doesn't happen like that. Everything that you uh, provide to the apps, they store in their database system, which can contain three types of data, right? So I will go through those three types of data in detail. But before I move on to that, any questions on what is data and what is database? I am very bad with examples, maybe. So if you did not understand that, just let me know.
No, as of now.
No, yeah, no queries.
Okay, so what about Mahalakshmi and Kartavya?
Yeah,
You guys
yeah,
are good?
everything is clear.
Clear till this point?
Yes.
Yes, yes.
Cool. So everyone with me. So let's move on to different types of data that we have in this world and how do we process them, right? So there are basically three types of data which surrounds us. First is structured data. Structured data is something which you can very much readily quantify. You can get some meaningful information out of it. For example, as Parikshit said in his example of what is data, he said like data is something called as name, age, phone number, right? So that comes under structured data category. So we can easily define a table with that information, right? So let's suppose we are having a table of SQL class, right? That we are having now. So in that SQL class, we can have table, we can have columns by the name, student name, occupation, age, phone number, and the class date, right? We can create columns like that, and we can insert rows in these tables, right? So first row might be for Ahmed. So we'll say Ahmed working in XYZ company, age is XYZ, and date of birth is some date of birth, right? Similarly, one entry will be for me, right? Shishendu, age is like 30 and working for some XYZ company and date of birth. Right? Similarly, we will have entry for Parikshit, Mahalakshmi, and Kartavya. So it will all be in a defined tabular format. Right? Everyone with me till this point?
Yes.
Yes,
Yes.
clear. Yes.
Yeah. So when we store data in a structured format, right? So it's very easy to read. It's very easy to manipulate, and we can easily make sense of the data that we have. So that this kind of data we call as structured data, right? So everyone clear on structured data? Let try to. Are you able to see my notepad?
No.
No.
Notepad you cannot see, right? Let me stop sharing and reshare the screen. Can you see the notepad now?
Ah,
Yeah.
yes.
So as I was saying, structured data, it will mostly be in tabular form, right? And tabular form means it will have rows and columns, right? So let's say we have this table SQL class, and we have rows like name, age, enrollment number, phone number, and date of joining, let's say, right? So we can have one entry for Mahalakshmi, age is like something XX, enrollment number XYZ, right? Some number, phone number is some number, and date of birth like 1/1/1991. Similarly, we will have records for all other students. So if you see, this record is very structured. We know if we want to select the name of all the students in this SQL class table, we can just write a query to select the names, right? We will get all the names. So this is structured data, right? Now, there is one more type of data which we call as unstructured data. So what happens in unstructured data? Let's suppose we still have to store this information, right? But in unstructured data, it will not be in forms of rows and columns. Somebody might be sending us a log file in JSON format, right? So it will have entries like name, age, enrollment number, phone number, and the right. So name will be some XYZ, some data, right? This is one record. Now somebody has made an entry for another student by the name ABC, right? And they did not enter two informations, like enrollment number and phone number was not there. And for some other student, only name is there, right? No other fields were provided. So this kind of data, if somebody will ask you, like, give me the enrollment number of all the students, will you be able to give? Will you be able to quantify? Hello.
Hello.
Yeah.
Yeah, it's like there is no data, like the information regarding it's not in a proper format.
Yeah, it's not like there is no data. We have data. It's just not readable, or we are not able to make any sense out of that data, right?
Correct.
So this is something we call as unstructured data, right? And okay, sorry, this is not unstructured. Extremely sorry. This we call as semi-structured data, right? It is partly structured. Apologies for that, right? So we have name, age. So in this we have name, and the last one we only have name. So we are missing some informations here. So this is semi-structured, means it's not all the way structured. And to store this kind of data, semi-structured data, we generally use NoSQL databases, right? And to store structured data, we use relational database management system, which we also call as RDBMS, right? So we will discuss in details on RDBMS, because to read any data from RDBMS or to write any data into the RDBMS, we use SQL, right? Which is our primary focus of this class. So we will discuss RDBMS in details. And now that we use structured data and store in tabular format, right? Which means we have rows and columns, and we store them in relational database management systems. So some examples of RDBMS are like Oracle, SQL Server, MySQL, right? So everyone are aware of these names,
Yes.
Yes.
right?
Yes.
So this databases we use to store structured data. So all clear on what is structured data, how it looks, what do we use to store them?
Yes.
Yes.
Yeah, you can make notes on these points if you want, and you need some time to make notes, or you can just take a screenshot if
No, in case like suppose you are recording this session and like are you going to upload those recording file into the particular path or share or something somewhere else?
Yeah, I think we will do that. I need to check with the institute, but I will keep you guys updated on that. Okay.
Yeah, thank you.
So, okay. So for structured data, we use relational database management systems. For semi-structured data, we use NoSQL databases. So NoSQL databases are very much in demand in market now. These were there for almost 10 years, more than 10 years, but were never famous. But in the recent few years, there is a huge demand of NoSQL databases. To give few examples of NoSQL databases, one is Elasticsearch. These are all document-based, search database systems. Like you have semi-structured data, you can store this kind of data in Elasticsearch, and then you can, if you query for name, it will only pick the name from these 3 records, right? And in structured data in RDBMS, a record, each entry that you see, right, this will be called as a record. Okay, and in semi-structured data, for which we use NoSQL databases like Elasticsearch, MongoDB, Cassandra, right? These are some famous NoSQL databases. So in these databases, unlike structured data, we don't call these entries as a record, but we call them as a document. All right. So this is on semi-structured data. And does anybody know why we call it NoSQL? Why the name NoSQL?
Because not
Because that is not a
in a
query.
structure.
It is semi-structured.
Yeah, all these answers are correct. So full form of NoSQL is not only SQL. Okay, you take N, you take O from here, SQL, NoSQL. It means not only SQL, right? So Cassandra is a NoSQL database which can store data in form of records, which means in a tabular format, right? So in Cassandra, you can write SQL queries as well as you can store unstructured data, right? And one thing, if you notice, right? So if I add one more record here, right? So this in structured format, what happens? We store the data in form of rows and columns. Agreed? This point is clear, right?
Yes.
So, okay, clear to everyone, right?
Yes.
Yes, yes.
Yes.
Okay. So in semi-structured, we don't store it as in this row format. It's just directly stored it as one document format, and it is a columnar storage. Means, it takes less space and it's much faster than traditional DBMS. So we discussed about structured, semi-structured. We have one more type, which is unstructured, right? Unstructured data. So by the name, you might have understood, right? So it's not in tabular format. It's not structured. It's not semi-structured. It's totally unstructured data. So the type of data that comes in this is logs. So we have logs, right? Some of you are already working. So if you run some application, you will see, a huge Unix logs getting generated, or we use Jira, right? So Jira at the backend will store all the Jira informations and they will maintain some logs, right? These logs are very hard to read, right? So when you install Windows systems, you will see some very high level commands running on your OS, right? On your screen, you'll see some commands are running. So somewhere someone stores that records, right? So these are very unstructured data. Means if you read it, you cannot make
Uh,
any sense out of it.
have a question here. What is the meaning of logs? Is that file or something database
Logs are
where data?
generally files. By the
Okay.
log, it means it's generally files. So like you're installing an operating system, right? Something in blue screen will be coming in the background, right? You will see something happening, installing this software, installing that software, installing this, right? Something will be happening. These are all logs. So we don't go through logs and figure out, right, what is happening, because it's very hard to read. So that we call as unstructured data. So logs are one example. The other example for unstructured data will be videos, right? Video files, images, because these are the things you cannot store in tabular format or as a document, right? These are all different file formats. Like video files can be in various formats, like MP4, then images can be in JPEG format, GIF format, right? So these are very unstructured and we can't store them in database systems. So that's why we call it unstructured. So these are the 3 type of data that we deal in our day-to-day life. Okay, and most of you might also have heard about the term big data, right? It's very hot in market now. People keep calling big data, right?
Yes.
So what do you mean by big data? Big data is something like all kind of data. Like I said, everything in the world is now data, right? Everything around you is data. So if you say Google, right? Google has so many company. Google bought YouTube, right? Google bought so many other companies. So what does YouTube do? YouTube, they have millions of creators associated with them who will create the videos, they will upload. So YouTube will have to store those videos somewhere, right? And to store that video, it will also have to store the information about all the person who has created the YouTube accounts, how many subscribers that person has. So for video, they cannot use structured storage, right? So they go for NoSQL storages, right? Or they go for cloud storages to store the videos, or some file system based storages, right? But to maintain the database of all the users, how many subscribers and all, they still use traditional databases like structured databases. So they will have SQL Server or MySQL. So I believe Netflix, uses SQL Server to a great extent. Facebook, I think, uses MySQL. YouTube also uses MySQL for their database. So there are very good use cases of these databases. So this was on the type of data that we see. I will just stop the share and reshare the PPT. Okay. So any questions till this point?
No from my end.
Yeah, I'm good.
No.
Okay. So in this particular slide, I have listed some differences between structured data and unstructured data. So as you can see, the first point is structured data can be displayed in rows, columns, and relational databases. Like we discussed, right? We store it in rows and column format, and we use RDBMS to store the data. And you can see here, it's a table format. You can see a small table here, right?
I have a
And
question here. What we call rows and columns in RDBMS data languages.
so
What we call.
so rows are the entries that you will make in a table. Like I took the example of students table, right?
Mhm.
The columns there were name, age, enrollment number, right? These were the columns of the table, right? And in these columns, we will have to store some values, right? Like I took the example of Mahalakshmi. I gave an entry as Mahalakshmi under the name field. Then age, I gave XX. So I gave an example like that, right? So that particular entry that we made, that is a row, right? So if you see this example, this XY 1 and 2, these are the column here, okay? And the values that you see A1, A2, B, B1, B2, these are the rows in the table. So always first field will be the column, and all the data that you insert in the table will be the rows. Clear on that?
Yeah.
As we move ahead, right, we will deal heavily with tables, and I'm sure you will get to understand more on what rows and columns are. Okay. So that was one difference. And in structured data, we can define data types, right? So as we have name in the previous example, name is a string data type, right? So it will be varchar or a character type, right? So similarly, date will be of type date, and any numerical values like age. Age will always be a number, right? So the type of age will be number, and we can define integers or decimal for the age field, right? So and this unstructured data, as you can see, we can store images, audio, video, word processing files, emails, spreadsheets, anything that we cannot quantify, we cannot store in structured format, goes under unstructured, right? So as I was saying, right, people keep on saying big data. If you see, if you consider the 100% of data in the world, and you can take a percentage of structured and unstructured data, you will see like only 20% of the data that we have now, right, is structured, and 80% data is unstructured, which we were not able to analyze till now. So every company who is trying to move to a big data domain, is trying to figure out how to make sense of this 80% of the data, right? This 20% we know we can handle using RDBMS, but how to handle this 80% of data? For this 80%, we have technologies like NoSQL databases. We have big data wherein we, create RDDs. We have Spark for parallel processing. All those hi-fi terms that you see now. So those are used to process this 80% of data. Now IoT is a thing, right? So what is IoT? You might have heard about smart devices, right? Smart lights, smart fans, everything you can control with your phone, right? Everything is connected to your phone. They are sending you continuous data. So all those data is unstructured, right? To process those information, the companies are highly investing in this part to process this 80% of the data, right? So, and as we know, structured data is well defined, so the storage will be less. Okay, so as we were discussing on the structured and unstructured data, so I was saying like only 20% of the data that we have now is structured, and almost all the companies are working on this 20% only, but there are still 80% of unstructured data that we are not able to process, and companies are investing very highly to find out a way to process this 80% of the raw data that we have. So the next point is like structured data definitely takes less storage compared to unstructured data, and unstructured data requires more storage because it's evident, right? Because we store videos, we store images, and videos can go up to 1 GB also, or more than that, right? So for a company like Netflix, they have like so many videos that they store, right? So they have a movie that they are hosting on Netflix. So for that movie, they will have to store the copy of the video in different resolutions, right? So there should be one resolution to play the movie in laptop, and if somebody is playing the movie in mobile, the resolution will be different, right? It can be 144p, it can be 1080p, different types of resolutions are there, right? And they maintain a copy of the video in each of those resolutions, right? So you can just imagine what kind of volume of database storage they be requiring for that, right? So, and structured data is easier to manage and protect with legacy solutions. When I say legacy solutions, it's basically RDBMS databases like Oracle, MySQL, SQL Server, Teradata, Netezza. So these are all used to manage structured data. And for unstructured data, we cannot use this traditional legacy solutions. We have to explore different ways, and that is the reason the big data has come into picture. Different processing engines like Spark is in market now to process this huge volumes of data, right? And we have NoSQL databases so that we can store and process this unstructured data, right? So any questions on this types of data that we discussed now? So you are all cleared on structured, unstructured, and semi-structured data,
Yes.
Yes.
right? So since we will mostly be dealing with SQL, we will only focus on structured data, right? And that is why we call it a structured query language. All good till this point?
Yes.
Yes.
Okay. So let's move on to the evolution of databases. It's just more like a storytelling, and you guys will feel like this is a history class going on, but that's fine. Bear with me for this introduction class, and from tomorrow we will focus more on SQL side. Okay, so let's move on to how the databases evolved over time, right? Like I said, initially it was a file-based system, right? So everything at a backend was just file. We have very basic computers back then in 1968, no advanced processors and all, right? So we were just storing data in terms of files. So the files were stored in sequential format, they were indexed, or they were stored in a random format. Jisko jahan mila, they stored, right? Nobody cared like which file should be stored first, which file should be stored later, like in the government offices. Like people just store the data, and then when somebody will come and ask for their file, they will go on searching the entire area or where that file was kept, right? So those kind of things were happening in the initial stages, right? So then the hierarchical data model came up. So this was first designed by IBM, right? So they called it as the information management system. So they had a hierarchy format, like a school is there. For example, I'm taking an example of a school, right? So we have a school. Now the school can have up to 12 classes, right? So each class will have, 30 students. Each class will have 3 sections: section A, section B, section C. So you see the hierarchy, how it is built. One school, 12 classes, 3 sections. So imagine it as a tree, right? School being the parent node, and it comes down like that, and each section will have 30 students, right? So that was something as the hierarchical data model which IBM has created in 1968 to 1980 time period, right? So after 1970, the first relational database was developed, right? And the model was proposed by EF Cod. So we call him as the father of relational databases, right? So what is relational database? It has two main terminologies. One is instant and one is schema, right? Schema is nothing but the table definition itself, how the table is defined, right? And instance is the table, actual table with rows and columns. So understand this. Schema will just give you an idea how the table should be designed, what will be the table contents and all. But the actual table that will be designed, we call it as an instance, right? And that instance, which is a table, will contain rows and columns. So after relational databases, till now, relational databases are going on in the market. We are still continuing. There are a lot of advancements that are being made in this area, and we are still using it, like Oracle, SQL Server, MySQL, Teradata, Netezza, all good. But the problem is, as we saw in the structured and unstructured data slide, this relational database is only good to process the 20% of data which is structured. That 80% of data is not structured. Remember that, right? So now what happened? Data is increasing. Scenarios are getting more complex. DBMS are getting very slow, right? So people are now moving to cloud databases. When we say cloud databases, it is nothing, right? So database, big companies, they have the data centers, right? In those data centers, they will have a lot of servers wherein they will install their database systems, right? So if they have to scale, that means they have to buy more data centers, which is again, going to be costly for them, because they will have to hire new systems, new CPUs, high maintenance, right? So it's a very costly affair to scale any database data centers for a particular company. So the companies are now shifting to cloud databases. Cloud databases, they don't have to do anything, right? There is no infrastructure cost. So biggest cloud player we know is Amazon Web Services, right? So Amazon has very huge infrastructure. They are spread across the world, right? They have a data center in Mumbai. They have multiple data centers in different regions in US, right? So companies just have to host their applications in their data centers. There is no additional cost, no setup cost, and it's like pay what you use. So if they are, storing in a particular area for a particular time period, they only pay for that. They don't have to, bring in unnecessary hardwares and keep maintaining them. Nothing. Just you have data, connect to their servers, dump your data. That's it. The amount of data that you dump, pay only for that. You don't have to buy the entire server, and all those issues goes away. And that's why Oracle Cloud, so cloud databases, Amazon Web Services provide few database services. Like we have Oracle MySQL, they have their own RDS stores. We call it, they have their own AWS application, which is called by the name RDS, which is relational data store. So they have their own cloud database, Redshift. It's an entire data warehouse. For RDS relational data store, they use PostgreSQL, which is similar to Oracle MySQL. And for NoSQL databases, they have Elasticsearch, they have MongoDB, and they have Aurora DB, right? So those are their cloud databases. So this was cloud databases. And then the last type of database is NoSQL database, which is currently picking up the market. We are starting to use, these companies are starting to adapt to this NoSQL database. They're trying to explore and see how they can use it for their benefit. All right. So this is some of the examples of NoSQL databases. So as I said, the full form of NoSQL database is not only SQL. So this is considered as an alternate to traditional relational database systems, right? In which the data is placed in tables. So this information you can relate to, right? Data is placed in tables, data schema is perfectly designed before database is built. This means it's totally a structured data, right? And NoSQL databases are very useful when you have a very large data set and it's distributed across different machines, right? So since we are moving to cloud now, so it might happen you have hosted your application into a cloud service, AWS, and some of your services or data is stored in India, some of your data is stored in America, some of your data is stored in Europe, right? So you need to bring data across all the regions and then do the processing, right? And in those kind of scenarios, NoSQL databases works the best. They are built for distributed processing. Okay. So this was on the history of database. So we started with files, right? Then we moved to hierarchical model. Then we moved to relational model, which is still, in play. We are still using it to process structured data. And then we have cloud database, wherein the infrastructure cost has been reduced, so we can process structured unstructured data in the cloud platform, and data is readily accessible over the internet, and the companies are adapting to cloud database because they are saving a lot of infrastructure cost in this, right? And then NoSQL databases, which is slowly getting adopted by different companies for to process unstructured data. So this was on some of the history of databases, the type of data that we process, and what is SQL and why do we need to learn SQL in today's world, right? So we will stop here for today, and I will take questions now. If you have, we still have 5 minutes left. So let's see if you have any questions.
Nothing from my end, Jason.
Yeah, nothing from my end.
So you guys got a hint, right? Like why SQL is important and what are the different type of use cases and how, when do we use SQL and when do we use NoSQL? These scenarios are very clear to you,
Yes.
because there
I
will
have a
be.
question here. How it's useful SQL in Power BI?
So SQL in Power BI, right? So Power
Yes.
BI, you have to build dashboards, right?
Mhm.
That by dashboards, I mean you will be building some graphs. Basically, you will represent the data into graphical format or some pictorial format, which will be easy for the end user to read the data, right? And to build those dashboards, you need to pull data from somewhere, right?
Yeah,
So
from database, right? From database.
right? So how do you communicate with database? As I said, I communicate with you in English, right?
Mhm.
So to communicate with database, you need a language, right?
Yes.
So that is structured query language, SQL, right?
Mhm.
So data in database, what do you have? Tables, right? So what is a table? Table is nothing but structured data in format of rows and columns,
Rows and columns.
right? And what is rows and columns is structured data, right? And how do we read structured data? Using SQL.
By
Because
yeah, SQL language, right?
yeah, and what is the full form of SQL?
A structured query language.
So now you answered your question, right? It's structured data in database. So we are using a query language to communicate with the database to fetch some records. And based on that data that you are fetching, we are building dashboards on Power BI. Okay. So Power BI is just a reporting tool. You will display some graphical interface, but at the back end, everything is SQL. Okay.
Yeah, one more question. Do we need to learn advanced level in SQL, like if we go for Power BI?
Not to a great extent, but you need to be, intermediate level. in SQL.
Uh-huh.
And we will cover that in our classes. So the topics that we need to focus more will be joins, right? How to join multiple tables to fetch the data. So then there are some window function concepts like aggregation, sum, count, rank, dense rank, concepts like union, all those things will be covered here. The filters, how do you apply different filters, right? How do you select which table to query first, get the data? So that will come from practice, and the concepts
How
that
about
you need.
store procedures?
Stored
Will you be
procedures,
covering?
we will cover that also. Yeah,
Okay.
it's very easy. Once you know SQL, stored procedure is just some extra commands that you need to learn. Everything else remains the same. So I will cover that also.
Assistant, just a small request. Could you please share the course module so we'll be able to know that what exactly it is?
Sure. The course module is already present with the institute. If you're in contact with Kavita or Meghna, I guess you can,
Yeah, one more question here. How long do you take to finish this course? But Megha said like you're gonna take classes a weekend, Saturday, Sunday.
yeah, Saturday, Sunday, and I will take in weekdays also. So that's
Yeah.
Oh, in weekdays also you take?
yeah, weekdays also I will take. So it
Mhm.
will be alternate days.
Mhm.
Maybe I will check with them. So I will try to take 3 days in weekdays, and 2 days in weekends. So 5 days a week, right? So we will try to cover it fast within a month. But it will
Okay.
take a month to learn it, and it all depends on how you practice it, right? I'll be there to help you, because I bring in all my industry experience here. So I will try to give you real-time examples how we do it in our real-time projects, what kind of
Yeah,
scenarios
but
we
it's
face.
problem only creating tables are difficult for us. Like if you're already tables, like we can easily practice. Like after classes, we can we can
So
easily practice.
there is a lot of online compilers. Even I will be using an online compiler for your training, and the commands that I will run, I will keep storing those commands like create tables, right? You can just copy those commands, create the tables, but you will have to play around. Like you try to insert some records in those tables, right? Try to join the tables. So those kind of things you will have to do from your end. That's how you will learn, right? If I give you everything and you will just do a copy paste, that way you don't learn anything, right? So yeah, we will make sure we will have enough practice sessions, right? And at every topic I cover, I will also focus on the questions which might be coming in interviews, right? Related to that particular topic. What kind of questions are asked in interviews? I'll also cover those, right?
Okay, Sishendu. Thank you
And
so much.
no problem. And in today's class, right, type of data. So this is a very common interview questions for freshers, like how many types of data do we have, right? And what kind of databases do we use to process this kind of data? So this is something you need to remember. Like we have 3 types of data: structured, semi-structured, and unstructured. And basically, when you enroll for any SQL classes, right, nobody will cover these 2 databases, like structured, unstructured. They will just, nobody will give you this information, because we only deal with structured data in SQL, right? So this is good to know, because
Yes, yes.
companies now are also focusing on this unstructured data. So if you are having a fair understanding of what it is, it will be giving you a top edge in the interviews.
Okay. Thank you. Yeah. Shashi.
Thank you, Susan.
Sure. So if there are no other questions, then we will stop this class today. And I think in the institute will communicate you on your next sessions, right? We'll wait for that.
Okay. Thank you.
Okay.
Okay,